All right, so let's start. We'll just wait for everyone, but yeah, they'll come. So again, my topic is about disaster recovery, and we will talk about more. And so I'm Paula. I am a site reliability engineer. I contributed Drupal since 2009. I started in Drupal 4, version 4, and I'm currently working at the Lino Venture Studio doing fintech application. And I worked before at Pantheon for 7 years and did a lot of migration stuff. And yeah, that's me. And I'm gonna talk about disaster recovery. All right. So here's the agenda. First, we will introduce introduction to disaster recovery. We'll talk about top IT disaster of all time. We'll also talk about security compliance that covers disaster recovery and SOC 2, ISO 27701, GDPR, and then we'll talk about disaster recovery strategies. And we'll do a demo. We will deploy latest version of Drupal to AWS using Terraform. And we'll try to do a disaster recovery exercise. Okay. All right. So what is a disaster recovery? Disaster recovery is the process of preparing for and recovering from a disaster. It could be a human error. It could be a data center in a country where there's a war that the operation is interrupted. The disaster recovery is actually part of your organization's resiliency program. And that is really very, very important, especially if you're running highly critical sites, especially for financial tech application, if you're processing payments and protecting very important data. I don't know if you know them, but they're really pretty famous in the Silicon Valley. All right, so first let's discuss the IT disaster of all time. The US Affordable Care Act, when they launched it, actually after 5 minutes, 30 minutes, they were down. Probably they haven't tested it so much. I think one of the issues here is that they haven't load tested the site. I think they expected 5 times more than, and then the website demand was really reaches to a million users. And the site weren't able to handle the traffic, and it went down. Again, there was a disconnect here. Second is Facebook, when one of their network engineers was trying to test the network capacity. So instead of making sure that the network is working, it actually disconnected all the data centers in Facebook, and it cost Meta of $47.3 billion of market value during that time in 2021. That's really huge. And of course, the most recent one, the CrowdStrike disaster. I think the most affected industry are the airlines. American Airlines, United Airlines, Delta Airlines. They have a lot of they grounded their planes because they weren't able to access their system due to this failure. So this disaster was probably prevented if they were planned their disaster recovery, and if they were really be able to restore it in a short span of time. I think even in the Philippines, in the Philippine Airlines, Cebu Pacific Airlines, they even have delays for days due to probably they have no resiliency program with regards to their whole system was shut down because of this CrowdStrike disaster. So let's talk about disaster recovery objectives. So there's actually two objectives that we have: recovery point (RPO), and then the recovery time objective. So what is recovery point objective? So, sorry. Let's there's a pen. Turn on the pen. Okay. So this is actually the point. So recovery point, this is actually where your reset backup. So if you back up in time of before the disaster happens, then that's good. But what if your recent backup is like hours or 2 hours before the disaster went down or before the disaster happened? And that's actually a data loss. And and usually for a fintech in the financial tech company, usually the recovery point is below an hour, so probably 30 minutes to 15 minutes. So on the DevOps standpoint, you should be able to recover that data within those 30 minutes to an hour. And I know that Pantheon, Acquia, they all have a disaster recovery strategy, but I think if you're looking for a very less than an hour, then I think that's where the technicality and the difficulty on implementing a disaster recovery. So, and then the recovery time objective, that's actually the time that is acceptable to your clients. That, let's say, right after the disaster, you'll be able to restore it in a matter of an hour or 2 or 3 hours. So in one of my projects, we have a RPO of 15 minutes and an RTO of an hour. So we have to restore. We have to make sure that the site is up and running in a matter of an hour. So, and how are you going to implement that if you only have, what if the whole region, if you're in Singapore, if your hosting provider is just based in Singapore and the whole region in the data center in Singapore went down, how can your disaster recovery remedy that? So that's really a pain if you have that kind of disaster. So you really have to think outside of the box, that we should have to have a multi-region. Let's say your hosting provider is in Singapore. If Singapore region went down or will go down, how are you going to implement that? Of course, you have to, maybe your disaster recovery should be located to somewhere outside Singapore, like Hong Kong or Tokyo or maybe in the US. All right. So let's talk about disaster recovery strategies. And there are actually active passive and active active. So what is active passive? Active passive is like the normal backup and restore. But of course, this is a lower priority use cases, especially if you're not really minding of data loss. And then you're not really minding of as long as you can back up 24 hours, you're good to go. So you can do the backup and restore strategy, and this is the lowest cost that you can have. And then next is and then the RPO. If you're talking about hours, then that's okay. But what if you're just talking about 10 minutes? 15 minutes of, then you go for pilot light. And pilot light, meaning you have 2 clusters, one cluster in one region, and then the second is in the other region. And the services there are still idle. And of course, it's not yet scaled. You have to make sure that you're being scaled. And the cost is, well, it's not that expensive than the backup and restore. You still have to shell out more money. And then the next one is the warm standby. And this is actually one of the top strategy that the financial tech usually do. So it's always running, both your 2 clusters, and it's also for business critical sites, and expensive, of course. And then you still have to scale it once you trigger. And then the second one is the multi-site active-active. So that means that the active-active is you have 2 clusters, one cluster running on Singapore region, and another cluster is running on probably Tokyo or in the US. And the only difference is that both of your users can actually log in. There's a connection. They can either log into your Singapore region, or they can also log into the US region. But what happens is they just disconnect the connection for the meantime. And then once a disaster happens, then they flipped the DNS so that they can access. So this is nearly zero downtime, the multi-site active, but very expensive. So most of the clients that we have are banks. So they have lots of budget for that. That's why they can afford to build an active strategy. So I think that's the beauty, is that near zero downtime, near zero data loss, because the database is replicated real time, and when it comes to the files, it's either you can use S3 or you can use EFS, and it's also real time. They can replicate the files, and that's actually what I'm gonna be doing like a while later on during my in my demo. All right, so active passive. So this is the active passive, the one on the left side. So as you can see, there's 2 regions. The first region here, especially, let's say this is in Singapore region, and this is the active. And then the passive, which is actually on the other region, let's say Tokyo, and it's on standby, meaning there's no workloads running in there, but there's already a database. It's being replicated. And once the region went down, then there will be a uplift in your DNS to serve traffic to your Tokyo region. And that's what we call as active-passive. And what about the active-active strategy? So for the active-active strategy, both of the regions are running, both of the clusters. Their replication is synchronized, your file system is synchronized, and when one of the regions went down, you're still alive because the other region is alive, but this is located in the other region. So this is what we call as multi-region disaster recovery strategy, but very expensive. That's why most of the financial tech, so why I'm always talking about financial tech? Yes, because I really want to impart my knowledge in the fintech to Drupal. So, yes, sir. Mm-hmm.
One was to become an effective how. That means the second one would be replicated and also be effective.
Okay, so when I say replication, we only have replication, database replication. On AWS, we have like database Aurora. So there's it has a malware scanning. And so we make sure that when a data is being transmitted, so these are clean and we make sure that we can prevent such issue. So yeah, did I ask? Okay.
Well, it was not really like to testify but it was like one was to get hacked some way, then that will be replicated to the second one.
Okay.
Is there like a virus?
Yeah. So when it comes to that, let's say somebody hacked into one of the regions, but this is in a separate account. So they may attack that particular region or particular account, but they will not be able to go through another region because it's in a separate account. So I think that's the one of the protection. So I think maybe it will be easier for the hackers if it's just in one account. So that's why we recommend for our customers to have a multiple account for one region, one account. So it will tighten the security. And the reason why we're getting at this because most of the fintech application they complied with such security compliances. So one of them is the SOC 2. So SOC 2 requires it has a wide coverage because it even requires people. You know, when somebody hires in the company, it starts SOC 2 compliance because the new hire should be able to have, their laptop should have the security standard that the organization has set, and they make sure that your laptop is working without viruses or malwares, or even maybe if one of the employees is installing LimeWire or something like that. So SOC 2 will flag that down, and that's actually part of SOC 2. And it's not just in people, but in terms of infrastructure, SOC 2 has a lot of things that needs to comply to. The infrastructure should have a lot of alerts, so that requires by SOC 2. And another security compliance is the ISO 2701. So this is the standard. Usually, banks requires this security compliance, and making sure that your applications running on your organization is adherence to ISO 2701. So these are your information on the financial, your employees' data, the intellectual property. These are the data that's being protected by the ISO 2701. And on Drupal, with respect to Drupal, that covers the file system of Drupal, and that should be protected. And second is when somebody is filling up information from users, that also covers by ISO 2701. And the last one is the GDPR. So GDPR's data protection in the UK. So if you're building application based in the UK, you should have this kind of security compliance. And so what if? Is it hard to make sure that your application is compliant with the security compliances? Yes, it's hard, especially if you're doing it in DIY. But there are certain application that guides you on how to be compliant with these security compliances. Like SOC 2, we're using in my previous company when we were trying to comply with SOC 2. It took us like a year and a half, or a year, more than a year, to have our compliance, because it's a DIY. But in my current company, we're using Sprinto. So Sprinto is a guide. It's a guide to be complied with SOC 2, and it only took us 4 months to be compliant with SOC 2. SOC 2 Type 1, and then SOC 2 Type 2, another 3 to 4 months, and we got the compliance for both. All right, so now I'm going to be doing a demo. So this is the architecture that I built, and as you can see, we have here a security group. We have so this is just in one account, just good for exercise. And we will be doing a disaster recovery exercise. So this is the development cluster. This is the production cluster. And we have here a disaster recovery cluster. And each of this cluster is running on ECS, on AWS. And this will be implemented using Terraform in this part only. So we will try to automate this. As you can see, as you've noticed, we have here a peering connection. So peering connection to all of these three clusters. Why did I implement this? So that I can capture data. I can copy the data from here, going to my another cluster, so I can copy it so much faster than transferring from region to region. So at least, even if these are in a different region, it seems that the data that is flowing is within the network. That's why I have here a peering connection. And and so since we are going to be doing a disaster recovery exercise, so our file system is being handled by Amazon EFS, and as you can see, we will be having two clusters. One is from Singapore, and the second, which is our disaster recovery, is from Tokyo. Our source is writable, meaning because that's the production. So this is this. So this is our production. And then we have our disaster recovery in Tokyo, meaning the file system will be synchronized from Singapore to Tokyo, so that when a disaster happens, when this goes down, this is go live. This will go live, and the files is already here, synchronized from the production. And here's the configuration of our Amazon EFS. All right, so let me show you the code that I have prepared. There. So this is actually, this is currently in public. So you can copy this. So this is a Terraform, and I'm going to be running this. But before you run this, you have to package your image, and maybe put it somewhere in Amazon EKS, AZR. So you can fetch your information from there, and then once you have done this, then you can run the Terraform. So so instead of running it, I did some video recording. So this is this. I'll just forward this. So as you can see, I ran it for 6 minutes to implement such a deployment. So Terraform init, then we do a Terraform plan to check. So first is I Terraform plan the VPCs, so I can fetch them, and then I tried to Terraform plan the next. So as you've noticed, it's now creating the VPC that is required to run my Drupal. Now that the VPCs are already, the subnets is already created, the route table is already created, then we can proceed on installing the other modules. Then we apply. So it will install the rest of the packages. So from the RDS, which is the database, the EFS is now trying to be created. So this is now in the southeast. This is actually the deployment of the production. So it's the region is in the AP Southeast -1. All right. So let's Fast forward this. So that will run for 6 minutes to complete all the components in the AWS. There. So now that the Terraform for the production is completed, we can now DrupalCon. So this is the load balancer for the production. So we can check this out. So this is the product of that deployment. So I'm using the Umami. It's even connected to the RDS. So as you can see, this is the URL. Southeast Asia Elastic Load Balancer, Amazon AWS. That's the URL. And I prepared the certificate, and I have a production URL, DrupalCon. No. So that's actually the DrupalCon. This is the production URL, which is actually connected to this load balancer. And if we can check, so if we ns look up the DrupalCon SG, which is the production URL, so if we ns look up it, it's actually using the Southeast Asia region, which is our current production. And what if later on that the whole region in Singapore is went down? How are we going to flip our disaster recovery cluster? So I was able to prepare a Terraform for our so again, running a Terraform to, let's say the whole region in Singapore went down, and now we can automate this. How many minutes? Okay. And then I'm trying, now that the production in Singapore went down, now I can automatically trigger this Terraform, or I can manually trigger this, and this will take 6 minutes to recreate. And after that, we will have another load balancer for. Okay, so as you can see, it's already completed the Terraform for the disaster recovery. So this is how it looks like in AWS as a Drupal Fargate. Yeah. So this is how it looks like in the AWS console. We have a running container on ECS, and by just running a Terraform for 6 minutes. So and now we have another region from Tokyo. So let's try to umami. So this is the load balancer for the Tokyo site, the one that we have deployed. And this is the load balancer. So what happens is, of course, you have to flip the DNS. Now I'm gonna be updating the DNS, so I can automate the setting up of the DNS. So here, I'm updating the DNS and save. And I can check whether it updates. Let me exit this. Okay. So now I'm going to be running an NS lookup. If we are, see, at that fast rate, in just a matter of seconds, my production is already shifted to my Drupal disaster recovery in Tokyo. So that's why our production is already up, maybe less than 10 minutes. And my database is replicated. My EFS is real-time and synchronized. I haven't showed you, but since our time is already up. But at least we have shown here that in just a matter of 10 minutes, we were able to be up using a multi-region disaster recovery strategy. So I think that's all, and the GitHub repository is actually available publicly. I can send that to you folks. So thank you again. If you have questions, just let me know.